Moving on to our next concept, we're going to be looking at valency. So, our valency is our combining power of an atom or a compound. Or we can also say that it's its binding power to donate an electron or accept an electron. So, if we actually just have a quick look at a periodic table, we can plug in these valencies. So, feel free to add these to your own. We have for first lot, +1, +2. Transition metals are a bit more varied, so don't worry too much about those. +3, +4, and then we start to get into negatives. So -3, -2, -1, and 0 for the noble gases. So remember, noble gases are helium, neon, argon, ones like that. So remember, we've got our metals, which are here. So with our metals, they will always be positive because they want to actually get rid of their electrons and give them to the other negative species. So remember, we always have our positive metal. So if we want to actually look at valency, so our combining power, what we actually need to do is to start off with hydrogen. So remember, with hydrogen, we have in the center our nucleus. Remember, it has 1 proton, no neutrons, and 1 electron. So with our hydrogen, it can't just live alone by itself. Remember, hydrogen can only exist as a gas, as H2, so 2 hydrogens at any one time. So if we're looking at our hydrogen, we need 2 electrons and 2 hydrogen atoms together. This comes into when we're looking with valency, so it's binding power, the donating or accepting of electrons. We need to look at something we call the shells. So remember, we have a nucleus of an atom, so we have our protons and neutrons here. We're going to look at the first 3 electron shells. So our first electron shell has a maximum of 2 electrons in it, our second maximum of 8, and our third shell has a maximum of 8 as well. Easiest way to remember this, remember helium is back up in our noble gases, valency of 0, so it has that full outer shell. And the next one along is actually neon, so it has its full 2 and 8. So, easiest way to actually show you this is to have a look at a specific salt. So we have sodium chloride here. We have our sodium. So we have 2 electrons in the first shell, 8 in the second, and 1 in the third. Then we have our chlorine. Remember, same convention. 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. So remember, our metal in our salt will always be positive, and the other species will always be negative. That's coming from our acid. So what the sodium actually wants to do is to donate this electron to the chlorine atom. So we end up with positive sodium and negative chlorine atom. These aren't atoms now because they have charges, so we actually call these ions. So the sodium now donates its electron, so it's a donator, and the chlorine accepts the electron. So remember, it now becomes a more negative species. So looking back, remember we had our hydrogen. What we can also look at, remember, we have 2 in the first, 8 in the second, 8 in the third. That's all we'll be working with so far. If we look at something like water, so we've got H2O, we've got oxygen. I've just drawn the outer ring. So we have 1, 2, 3, 4, 5, 6 electrons in the outer shell. Remember, H2O, so there's 2 hydrogen atoms, 1 oxygen atom. So we have 1 oxygen atom, and if we actually looked up on the periodic table, it would be here. So -2, which means that it needs 2 electrons to satisfy it. So what we actually do is we look up hydrogen, which is +1. And remember, we have 2 hydrogens here for 1 oxygen. We have to fill that whole shell as 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8. If we take the electrons from each of these hydrogen atoms, we turn these into positive hydrogen ions and a whole oxygen with 2 negative ions. So these actually end up sharing together. Instead of being a bit like this one with the sodium chloride, where one ends up being positive and one ends up being negative, this one we actually have some electron sharing. So these two actually share, and these two actually share. So the oxygen together has 8. This hydrogen has 2. This hydrogen has 2. So that's why we actually have H2O. So 2 lots of hydrogen, 1 lot of oxygen. So let's look at this back to what we were doing with our acid and our metal. So using our example again, we have calcium and hydrochloric acid. So let's write them down. We've got our calcium and we've got our hydrochloric acid. So let's try and look at our periodic tables again. You can check yours in your books. Looking at calcium, it has actually a valency of +2. So it'll be in this column. So coming back to here, so we can write +2 up here. Because what we're going to be doing is actually balancing the charges to make sure that everything is balanced. Because we have to balance the charges and we have to balance the amount of atoms to make sure that the whole equation is correct. So we've got our valency of +2 for calcium. With our hydrochloric acid, we have 2 species. So we have a hydrogen, which remember is in +1, and we have our chlorine, which is in -1. So what would our valency be for hydrogen? And what would our valency be for chlorine? I'll let you think about that one. So remember, with our equation, we have calcium, so we have our metal and our acid producing our salt and our hydrogen. Remember, hydrogen has to be hydrogen gas. It can't live by itself. It has to be hydrogen gas and share those electrons to have 2 electrons in that first shell. So we have a chloride formed, so Cl, and we have our calcium ion, Ca. So let's look at the valencies. We've got calcium, which is 2 from before, and our chlorine, which was -1. If we've got +2 and -1, overall we want that to be 0. So we actually need 2 chlorines to be present. So if we do what we call swap and drop, so we swap it, and drop it. So this valency will tell you how many atoms of this you actually need to have. So you swap it and you drop it. So one other way you can look at it is your valency for your calcium is +2 and your chlorines is -1. So you want this overall to be 0. So 2 positives, 1 negative. If you add an extra negative, so 2 positives, 2 negatives equals 0. What else did we have to look on here? We've got our hydrogen as well. Remember, valency of +1, and we've got 2 hydrogens present because remember, they are sharing two of these electrons together to make hydrogen gas. So we've actually now got a case where we've started to balance it. So we've got 2 hydrogen on one side and 2 chlorine on this side as well, but we've only got 1 hydrogen and 1 chlorine and 1 calcium. So first things first, we need 2 more hydrogens and 2 more chlorines. So what we do, if you've got just one thing, you can put your number below, what we call a subscript. But when it's for 2 things together, imagine there's imaginary brackets. Just like an equation, we're going to put our number, our coefficient, sorry, out the front. So our 2 here means that there's 2 hydrogens and 2 chlorines. So 2 hydrogens, 2 chlorines. Remember, these brackets are invisible. So have we now satisfied our equation in terms of the amount of atoms that are present? So we've got 1 calcium over here, we've got 1 calcium over here. Your products must always balance with your reactants. We've got 2 hydrogens, we've got 2 hydrogens, we've got 2 chlorines, we've got 2 chlorines. We have a balanced equation. Lovely. So, just moving out again, this is what we're looking at, and let's move on to the second part.